Hey, what's going on, YouTube? How's it going? Welcome back to my channel. Let me confirm. Okay, we're on YouTube. Now I have to click this button, and now we're on Twitch as well. How's it going, everybody? Welcome back to my stream. Welcome to the Farewell Calculus Tour. Farewell Calculus. I will explain what that means as we go. We will be saying farewell to this wonderful, beautiful book that I can't recommend more highly. If you need to learn calculus, this is the one. This is the one for you. I like this book a lot. I'm not sponsored. I don't think math books sponsor YouTubers yet, but it would be really cool. It would be really cool if we could get sponsored. What's up, Geometry? How's it going, dude? How's it going? Geometry, what are your feelings about calculus? Have you been to the calculus streams before? I should explain to newcomers what is happening. Well, first off, hi, my name is John. I freaking love math, and I'm here to share my enthusiasm and passion in math with you all as I come back and relearn it and try to learn it better than the first time around. What else? I have been streaming in a weekly cycle structure. Here it is. This coincidentally is still the notes from last time that we streamed here. I don't know if I said today is July 13th. Last time we were in calculus was about a month ago. June 18th was the last time. We are live, if that's not obvious yet. There's going to be a lot of yapping. This is going to be very unstructured, and I want to explain to anybody watching these videos after the fact, this is not my introduction to proofs course. Okay, this is not the course. I'm sorry that is so confusing. I don't have a great solution other than just wait until the next episode drops. I keep trying to finish it, and it's just not good enough. I feel I'm pretty good about letting go of perfectionism, but I finished a take last night, and I was just like, this is not it. This is not the one. So maybe tonight. Maybe we'll get it tonight. It feels important, but it always beats my intuition every time. What, calculus? Yeah. Oh, that's interesting. Yeah, it always beats your intuition. I don't know how I felt about my intuition with it. I feel like I felt I got a decent intuition with calculus. I never got a great intuition with analysis, though. So I'm curious which type of calculus you're talking about. We will be spending this week on limits from this terrific book. And I don't know. It's funny because I keep joking that, in calculus, you spend a couple of days on limits, and then you got to keep moving to, cover everything that's on the AP exam. But then when you go to college and you become a math major and you take analysis, then you spend your entire first semester on limits. It's crazy. It's so different. Theoretical math major calculus is just so different. Are we solving any real world problems? I was going to. Funny enough, I was going to. I want to learn application problems. But my inherent bias is no. My inherent bias, dude, is no. I don't like that stuff. I don't want to live in the real world. Dude, I want to live in this beautiful world that is just pure logic, and these are just little puzzles, and they're just fun. There's no utility to it. We just study this because it's beautiful. So, yeah, swap her. I don't know, just give it a try. It's not for everybody, but pure math is purely interested in math. It's okay to me that there's no applications. It's just really pretty, right? That's the difference. So please start. I need you need this so bad. Okay, well, I'm sorry, but this is not going to be a very good way to learn calculus. Tell me, geometry, what topics? Can you give me specific problems or concepts, topics? because we could just forget this and just like take some questions from the audience. I don't know. But my plan was this week, we will say farewell to calculus by focusing again on limits. So here is the table of contents. So Taalman's book is really terrific. It does a really great job focusing on intuition primarily. Intuition is very important. And it is not a theoretical calculus book. It is not an analysis book. But it's also not just a skills, problem-solving applications book either. Like, it's not really fair to say that Stewart is that. Stewart is still nice, and it has a wide variety of exercises. It kind of gets a bad rap sometimes, but still, like, a lot of people will teach Stewart kind of skipping over the conceptual stuff. It's just not emphasized in Stewart the way that it is in this book. This book is just so good. So I think that it's right. This book is right in between, to me, right in between Stewart and Spivak. Like on Reddit, if you go on Reddit and people say, what calculus book should I learn from? People say, oh, your options are either Stewart or Spivak. And it's like, no, we need something in between. Those are totally different. Oh, the video below. Yeah, let me change that. I forgot. We got people in the chat now. Thank you. Yeah, so there's stuff in between. So I like to have these Hawaii videos up. That was from my recent trip, and I like looking at them. I think that they're nice. Hey, geometry, let's go, dude. I don't know, I'm a frickin' newbie. I'm 14 in India, pressure of board, so I can't explore much. Dang, dude. Well, you're trying to learn calculus and you're 14. Like, when I was 14, I didn't like math at all. Like, I feel like I disliked math when I was 14. I don't know. Hey, Benjamin, good to see you. Limit finished. Kind of. This is the farewell calculus tour. Let's fix this. Here we go. We are currently on the farewell calculus tour this week. This is going to be fun. No, this week is mostly going to be real analysis, and I'm okay with that. Like, if we are not doing a full, long treatment of this book and working through all the exercises and trying to pretend that I'm, like, practicing in order to teach, high schoolers how to pass the AP exam, like, I think it would be better to just say farewell. Farewell to calculus. Like, right now, my professional ambitions are actually younger, which is super cool. Like, I really like working with, like, middle schoolers. So, we've got, like, here we go. So we're going to do another week, last week on calculus. So let's all say farewell to freaking calculus. High school, college, grad school. I don't know why I didn't finish writing this. I got distracted or something. Here we go. Grad school. There it is. High school, college, grad school. For anybody who's new, I believe very much in a space repetition approach. There's these two algorithms in computer science called depth first search and breadth first search. One of them gets you depth, and then the other one gets you breadth. And I'm not going to try to give a quick explanation of that, but the way that I've been thinking of these streams as spiral learning is kind of getting the best of both worlds. Like, I'm always looking for, like, oh, we've got this one and this one. Can we find a middle path, a middle solution between the two that, like, gets the best of both? So I think spiral learning works really well for me. It's essentially adding space repetition and breadth first search. So we keep coming back and we keep resetting and going in a little more depth every time. So we keep resetting, but we keep getting to harder problems every time. Yeah, thank you. Thanks for the thanks, or for the congrats, Benjamin. I can't believe it, man. 2 to the 14 today. We just hit we just got 14 students in my class. That's crazy. That's crazy. We've got 14 students now watching me. Hello world. How's it going, Diane? How's it going, everybody? Now I find it interesting to learn, but hated it in school. Yeah. Well, that's a lot of us. I didn't grow to like math. Like, I was decently good at it in high school. I didn't have to work that hard. But then when I went to college and I discovered linear algebra, I was like, whoa, this is really pretty. This is completely different than anything I've seen before. Like the abstract, proof-oriented form of linear algebra, especially the theory of vector spaces. And my professor did a great job picking a book that prioritized that, even in the introduction course for engineers and everything. So, well, what is gone, it is gone. What do you mean by that? Like farewell calculus? Bro just did print hello world, I guess. Okay. Like, hello world, my name is John. I am a math enthusiast. Do you understand the Curry-Howard correspondence? Yes and no. I could not teach it, at least. It's proofs and programs are equivalent in some way, but I don't know. Type theory, something or other. Let's get back to actual math. Once again, anybody who's watching this VOD, this is not intended to be an organized math lecture. This is a this is a live problem-solving session where I'm going to try to get some work done, and you all can hang out in the chat while I try to practice, because I just want to get really good at math. If you have to give one advice to students... what is your question? You'd rather have 1 million subs daily or double your subs every day? I guess you chose the second one already. I don't want either of those. We got too many students in the class already. And I'm just going to have to learn. I'm just going to have to learn on the job right now. Like, okay, I think I can handle 14 children. 15 might be hard. I really don't know if I can handle 20 children, dude. Okay, if you have to give one advice to student who is just starting doing math, specifically calculus, but the condition is he or she knows nothing. Ooh, okay. Interesting. If I were to try to teach calculus to somebody who knows nothing... Okay, that's a cool question. I like it, actually. Because I've never tried giving this idea. I mean, I've thought this a lot, and I've played with the idea, tutoring with some kids, like to teach fractions and adding fractions. Let me try. Hey, heck yeah! You enjoy the basic or the basic math video that's like popping off and getting me too much attention. That's awesome. Yeah, math can be a hobby. I know it's a hobby. I know a lot of people who have math as a hobby. I would hang out with adults, with my coworkers at meetups, like just for funsies, just to learn some math with like 2 or 3 other people. So like, dude, math, it's niche, but like it can be a hobby, and some people really, really get into it. Okay. How would I explain calculus to somebody who has never seen calculus before? I'm going to try to do something different. Here's calculus, in my opinion. And it's something I've tried to teach kids, honestly. I'm not joking. I'm not being sarcastic about that. I really do think this is not a bad introduction to calculus. Intro to calculus from Okay, all right, here we go. So one of the exercises, one of the practice problems that I give all my students is this. Okay, and I've done this in the frickin' basic math video, episode 1, I believe. Okay, these are called the triangle numbers, and Gauss found a really beautiful proof for this. They form a cute triangle, and the nth triangle number adds like as n times n plus 1 divided by 2. So this last one, 1 plus 2 plus 3 plus 4, I know is equal to 4 times 5 divided by 2. 4 divided by 2 is 2, 2 times 5 is 10. So that was fast. If I made this, if I change this just ever so slightly, oops. Yoink, let's move these dots over here. Let's put some new dots in here. This is just for fun right now. Okay, so if I was asked to add the first 40 numbers, or the first 400 numbers, that would take a lot longer to do one at a time. It would take 399 additions, and I'm not that good at addition. That would take me a while. Okay, all I have to do here, let's tweak it. Why don't we add this as a fun little kind of thing? Okay. Well, that's going to be equal to, notice that 400 is 4 times 100, and 500 is 5 times 100. So I can split those out and say that this is the same as 10 times 100 times 100. And this now is 10 times 100 times 100 has 4 zeros. And this now 1, 2, 3, 4. Boom. Okay. So that was fun. I've never tried this. I've never tried that frickin' twist or something. That's kind of cool, I think. But I'm getting distracted. Those are the triangle numbers. Let's do it again. That was fun. I enjoyed that. Let's get back to the same triangle. This time let's tweak it. 1 over 1. 1 over 1 plus 1 over 2. 1 over 1 plus 1 over 2 plus 1 over 3. 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. Right? Okay, so this was a tweak. I wish I used a different color, but whatever. You know, maybe next time I will. So this first one, 1 divided by 1 is 1. That's not hard. The next one, and why don't we go ahead and simplify all of these? I know, just, you know, it's going to look a little prettier if I clean up my solution just a little bit. So while I'm at it, well, that's the only one that I can rewrite right now. Okay, next one, 1 plus a half. So, little children, anybody know the answer? Anybody know the answer? I wanted to see the first answer in the chat. Somebody, you all need to actually, I'm going to stop until somebody answers my questions here sometimes when I feel like it. I believe in chat today. 3 halves, wrong. This is 1 and a half. All right, next one. 1 and a half plus a third. What is that? We got 3 people who said the wrong answer. Let's go. I thought so. I fucking thought so. All right, don't invite any. All right, streams are PG-13, and I'm allowed one F-bomb. Okay. I hope you enjoyed that. That was fun for me. Okay, so 1 and 5/6. There we go. There we go. Thank you all. That's exactly right. I've never seen that notation X flyers. 1.1/5. Oh wait, 1.1/5. I don't. No, that's not it. But that's okay. Nice. Unless I'm misunderstanding it. All right. So let me do this. Let me really highlight this idea here. Okay. The previous number is still, it's right there. So I can just remember that we're going, like, it's easier to think of adding these two. So this is the same as 1.5 plus 1/3. I'm so glad 3 people got it wrong. I love that. I mean, so obviously it's not wrong. It's not wrong. What you all answered is correct. It's mathematically correct, but where we're going, I actually want to prefer the mixed numbers. Yeah, I know. I'm dismissing your answers. I'm marking you wrong, but that was just for effect. You'll see why, I think. So, somebody here. No, I hope somebody out there knows where we're going with this. So what is a mixed number like this? This is just notation that means 1 plus 1/2, right? 1 plus 1/2 plus 1/3. I can add 1/2 and 1/3, right? And I remember that I need to do this funny thing about tripling this one and doubling this one in order to get an LCD, right? You find the least common denominator, which is the least common multiple of the denominators, which is kind of confusing, but what I did, I know that this is, I want this to be accessible to everybody. To convert a fraction like 1/2 to a 1/6, you multiply it by 1. And multiplying by 1 keeps the number the same. Okay, just want to make sure everybody's on the same page as to why this next one will be 1 and 5/6. Exactly. Okay. Next one. Let's do the same process. So we are going to take 1 and 5/6 and add it because that was the previous answer, and now we're going to add a 4th to that, right? So what is 1 and 5/6 plus a 4th? Chat, somebody help. I don't feel like doing this one, so chat, help me with this one. Just joking. Okay, so I can do this. I can do this kind of math. We do this, right? If you add the two, the fractional parts, we get this, right? Nobody answered? I already stumped you all? I already beat you all? Come on, dude. All right, so this is what we would get, but we're using mixed numbers. Remember that, okay? So this thing overflows. This is more than 1. 26/24 is more than 1. But even before I do that, I'm going to have... Well, no, let's just do it. No, I can do it in one step. This is nice. Okay, so if I reduced that fraction, 26/24, it would be 13/12, right? And then 13/12 overflows by 1. So this is 2 and 1/12. Okay? Next. I'm going to start using this. And in this case, it was the previous. Okay. What is it? This is fun. this is just fun right now. We're allowed to do this, and I think that we could all use a little bit of arithmetic practice and practice adding fractions, because it might have been a while, and this is actually kind of cool. What is this one? 2 and a 12th plus a fifth. I need to multiply 1/12 by 5, and then 1/5 by 12. 12 divided by 12, I mean. So that would be 12 plus 5, which is 17. That doesn't sound right. 2 and 17/12ths? Something went wrong. Oopsie, that doesn't sound right. Where did I go wrong there? I need to multiply 12 by 5, so 5 plus 12 is 17. What's going wrong? Oh, I see it. Yeah, it's 17. Oops. That was a happy little accident there. It's 17/60ths, right? Because I forgot that I converted the numerators, but I forgot to convert the denominator, which is 60 now. That still didn't overflow, so we're at 2 and 17/60ths. So now I hope that I've convinced you that this is much nicer than if we had kept with improper fractions, right? Like, I hope already I've convinced you that this was much easier than if we had done this with improper fractions. And the first time that I've ever tried this myself, I used improper fractions, and I was just like, this is fun. I'm doing lots of calculations. Like, I'm practicing my arithmetic, and it was fun. And I filled the page, and then I started the next page, and I was like, oh, that was kind of silly, actually. Now that I think of it, on a brand new blank page, this would be easier if I just use whole numbers. If I just use mixed numbers. Oh, mixed numbers are actually useful for something. And they are. Like, I kind of wish that we didn't all just think that mixed numbers are not useful or something. Like, they are, to like know what the number actually is. And like we can get used to that, thinking like, oh, well, clearly the denominator goes into the numerator so many times, so this is like a little bit more than XYZ. But if you are answering a question like this, it's actually going to get hard if you do it the other way. So now we have this pattern. That's popping up. This is like the previous answer. Often in these kinds of sequence problems, we've got the nth term, and then we convert it in some way to the previous plus, like the new one is the previous plus something. So I could even do something like this. I'm going to name it H. Hn is Hn minus 1 plus 1 over n. Okay? So this is a sequence. Just like the triangle numbers, the Fibonacci numbers, and other sequences that we're going to see. But this is just addition because it's fun and kind of neat. Like, let's just play with some numbers. Let's play with the numbers 1, 2, 3, 4, 5, 6. What are, do we need more mods in the chat? What's happening? Shivansh, What's going on here, dude? Too many children, dude. We've got 14 children now in the chat. What is happening? Yeah, just keep it chilly. That's the only rule. Only rule. Don't forget the only rule. Keep it chilly. Okay. Sequences are like this. So here is the definition of this cool sequence, of the fraction practice sequence. So this is a terrific way to practice adding fractions. Easy mode is proper fractions. Hard mode is improper fractions. Often it's the other way around. Often it's like improper fractions are just going to be easier to work with. Wow, 16K. Yeah, we got 14 children now in this classroom. We just hit 2 to the 14. And that's too many. Man, it's too many. But I think I can do it. I think I'm ready. Like, I feel like I'm like Rocky. I'm like, yeah, let's do this. Like, I'm waking up and I'm eating eggs and stuff. Dude. Yeah, we got 14 children in the classroom now. Thanks for watching. So I think that this is just a fun way. Like, you can spend an afternoon doing these and just find these delightful little numbers and convert it. Try this with improper fractions as well and get really good, like crazy good at your multiplications and your additions. Like, if you want to like beef up your mental math game, like, do this with improper fractions and, you know, just check your ego at the door. This will get hard. But you can do it. Like, you can totally do this. Like, it's worth it. It's better than TikTok, man. Like, so in this one, let's see. That's an nth harmonic number. Oops, spoilers. We call this the harmonic series. And it pops up in nature and things like that, but who cares? This is math class right now. So similar to this, I want to ask, because we've done a bunch of these, like, maybe we could just do one more, because this is kind of cool. You could, if you're curious, if you still have tokens left, you could find out, this is approximately equal to some kind of decimal number, right? Like, you could practice this 3 different ways. I've never thought of this, but like, you could try to practice this with decimals, rounding. Like, dude, if you truncated every time and only took like 2 round to like 2 sig figs or like 2 decimal places, which is essentially, usually, it depends, but like most of the time that'll be like 3 sig figs or something, 3, 4. Okay. So these are like just different kinds of, ways to practice this one. Like, if you want to try to get good at mental math, which is just the most fundamental skill. Like, if you're not good at mental math, the rest of math is gonna be hard, I think. Like, I don't know. I was decent at mental math. It never held me back, I'll say. I was not great at it, but like, it never held me back. I want to try one more. And I'll just use this notation shorthand now, because now that we've defined this is the sixth harmonic number. It's going to be not 6, 7. That's just, accidental reflexes. I can't help but write 6, 7 all the time. H6 equals H5 plus 1/6. This is now the new kind of pattern. So that is H5 was 2 17/60 plus 1/6. This one isn't too bad to calculate. Can I move these? Not without, let's just erase them. 2 17/60 plus 1/6. Common denominator is 60. 2 27/60. 27 and 60 are both divisible by 3. So that would be 9 9/20. Yeah, 2 9/20. So now, this is like close to 2.5. Right? 9/20 is very close to 10/20. This one is a little further away. I mean, half is 30/60. So I want to know, because this is getting bigger. This is getting bigger every time. I'm going to ask ChatGPT. 17/60 is about 0.28. So this is about 2.28. Help. I need help. 0.08. Okay, so this one is approximately 2.08. Okay? And then this one was 1 and... what is a sixth, class? Does anybody know that one memorized? A sixth is half of a third, because a sixth is equal to 1/2 times 1/3, right? What is a third? A lot of us memorize that is 0.333 repeating. So a sixth is half of 33 repeating, which is this other one. It might sound familiar. 1.16 repeating. So at least this one I can write exactly equal. Not like we're not dipping into the fraction into the rounding anymore. So now I've got a table that I can build. We've got hn. For n equals 1. Hn. This was just 1 plus nothing. When n is 2, this would be 1 plus a half, which was 1.5. Let's use this for now. It's now a little easier in this way. Now the third number, was this one, 1.16 repeating. Something went wrong. That's like that's like in software. We always, when something goes wrong, it's conventional to say something went wrong. I forgot to multiply that by 5. Yeah, there we go. So I should have subtracted 0.16 repeating. There we go. Okay. So if I subtracted 16 from frickin' 100, then we would have 84. But then we'd need to keep subtracting more 6s forever. So this is going to be 83 repeating. Yeah. There we go, dude. 1.83 forever and ever. 4. When, for the fourth number, we've got about, what did chat say? 2.08. Did I not write? I think I accidentally double tapped to undo. All right, so this one was 2.08. approximately 2.08. When 5 is, or when n is 5, the nth number in this sequence, 2.28. This is just fun. I got nothing better to do right now. I'm unemployed and I'm looking for a job, so I got to fill my time with quality. I'm just trying to find quality time. What is 9/20 if I get a little more precise? 45. Now that I am asking chat. 2.45. Okay. I'm having fun with this. I'm still having fun. So let's do the next one. Now that we're dipping into the decimals, now this one is going to be... Let's just recognize that now we're going to be propagating errors. Like, we've rounded, and now we're going to round more, and now we're adding two things that have both rounded. So I no longer trust this answer anymore. I'm becoming an engineer. Like, at this point, I'm only interested in the answer, or like approximately the right answer. So what is 1/7? Do I remember that one? 1/8 is half of a fourth. A fourth is 0.25. Half of 25 is 12.5. So 1/8 is 0.125. 1/7 would be a little bit bigger than that. Is it 0.14 something? What is... Who cares? All right. I'm just having too much fun right now. What is 1/7? Yeah, 142. Okay. So I got two decimal places. Let's go. Which is all, I'm an engineer right now, so I only care about two places. 2.45 plus 0.14 would be 2. Yeah, what color is engineering? It's not red. Let's go to yellow maybe, or blue. Let's go to blue. 2 point, if I add 14, what is 45 plus 14? 59. Okay. So I want to see if we just, let's just analyze this. Let's be researchers right now. Like, what can we say about these numbers? This one increased by 0.5. This is a common pattern in math. When we're studying patterns, we spot a pattern. Let's see, in this sequence, can we compare terms? Like, how do I get the next one from the previous one? So between these two, we added 0.3 repeating forever and ever. And in this one, we added, okay. In each one, we're adding 1 over n, right? And this thing is going to keep getting smaller. That 1 over n, when n is huge, like if you have one pizza and you invite 1 billion people to eat that pizza, everybody's going to get a very small slice of pizza, right? So this is going to keep getting smaller and smaller and smaller. But we're still adding, in this case, 0.14, etc. I wonder, dude, is there any point, we're always adding numbers. We're always adding something. 1 over n is still a positive number. 1 over n is still a positive number. And we're always adding positive numbers to our previous answer. So what is the next term? It's always, eventually we're going to get to any number. And it might take a while because we're taking smaller steps. But I want to find out, when is this bigger than 3? I want to challenge you all, if you feel like doing this on your own, how many times do you have to play this game just for funsies instead of TikTok? When will this sequence be bigger than 3? Because, like, it should, right? We believe that it should. It should eventually be bigger than 3. I've done this before, so it's, not worth it to me to complete this. If I remember correctly, it's 11. Sorry for spoiling. You should have paused the video. At 11, we finally overflow the fraction, and we get like a very tiny number right there. But we finally found something bigger than 3. And in the process, we got super good. We got super good at fractions, y'all. So, it doesn't feel like a waste of time. It just doesn't feel like a waste of time to me. Thank you. So, why is this calculus? It is and it isn't. This is not surprising. It's tedious. Super tedious, but if you're the kind of person who likes just playing with numbers, it might be a good way to fill the time hundreds of years ago when they didn't have TikTok. So, like, I don't know, man. You might do this for a while. Then, I think that the next natural question is, okay, we love these numbers. 1 and 2 and 3, ... We love these numbers. Let's do 4. Let's just do one example. And I'm going to modify this sequence. We had a sequence, but let's invent a new game. This is like the sequel or something to the previous game. So this is the same as 1 plus 1/2 plus 1/3 plus 1/4. But this time, the twist is that I want to square all of them. Okay? This is just hard mode. I feel like the previous game just started getting a little too easy. Right? So let's do this one just for funsies. This would be 1 over 1 plus 1/4 plus 1/9 plus 1/16. 1 plus 0.25 plus, what's a third of a third? It would be 0.1 repeating. And then what is a fourth of a fourth, or half of an eighth, would be 0.0625. I'm an engineer now. This is going to be about, I'll take 2 sig figs. 1 plus 2 decimal places, so really 3 sig figs. 25 plus 11 plus 6. 36 plus 6 is 42. So that's 1 plus 0.42, which is about this. Okay, so dude, is like legendary mode or something. What's the phrase in like those video games where the hardest mode is something legendary or something, or invincible? Like you have to play the game and you can't get hit or something like that at all. Like something kind of silly. This is like legendary mode. When will, I mean, in other words, i.e., this sequence is much slower. It's much slower to grow because oops. Well, let's just compare. I forget. What is H4 exactly? H4 was 2.08. Okay, well, maybe this isn't as exactly dramatically different. So maybe you're confident, like, okay, well, we'll get there eventually. If the last one took 11, this one is going to take, like, I don't know, let's guess, 20. Let's do it. Let's do 20 additions. And you do this, to find the 20th one in the sequence. Because these two aren't that different. These two actually aren't that different. I was thinking of H11, which is 3 point something. So, okay, like, this is a little harder, is what I should have said here. Dude, HN is, like, harder. Like, a little harder. But, so let's ask, when will this new sequence be bigger than 3? So practice and find it for yourself. Go practice. To me, this is calculus. Does it grow slower because we divide to bigger numbers? Yep. Yep. Let me read chat. Let me catch up with chat. My neck hurts, dude. I've been looking at the iPad and my phone because I have so many subscribers now. Like, I've been looking at my phone so much that my neck freaking hurts. It's killing me. Math is good for the brain. It is. It really is. I haven't played Minecraft after the 1 point. I hope you all enjoyed this, dude, because I've never fully had the time to spend 30 minutes or whatever doing this one. It's been in my head. I've done a little bit, like a few of the harmonic sequence terms. I think it's a cool way to introduce adding fractions. This is our game that we're going to play today. Here's our new video game. New game just dropped. Like 1, 2, 3, 4. These numbers. New video game just dropped. Let's play this one. Fractions are friendly, way better than approximated decimals for kids' brains. Are they? I mean, they are and they aren't. I mean, yes, because like decimals, unless you can like really remember some of these tricks that I'm using, once you have to go to like the long division approach, it's like, dude, this is so boring. I'd rather be playing outside. Like, that's what long division kind of is. And so, there's other ways to find decimals other than the long division way, which is like, dude, I'd rather ask ChatGPT, honestly. Kind of. I mean, like, long division's not terrible, but between the two. Sorry, I don't have any great advice, but to just start practicing if you want to get better at it. It doesn't have to be a dedicated practice session or anything, just some stuff in your free time. What are you asking about? Oh, learn the basics of math so I can change to shopkeeper or count it faster without getting scammed. Oh, that's super interesting. Wow, like you want to learn how to count or like how to have better mental math or something, like better addition or something. Gothslayer, I really think that these kind of math tricks that I'm doing right now is perfect for you. So go watch episode 1, um, where I introduce Gauss's favorite numbers or something. Gauss's trick. I should just call it Gauss's trick. Like, I think that was super freaking clever. And what we did today was just modifying Gauss's trick. We started with this, and Gauss found this trick, this incredible trick, which you can see in episode 1, to convert something that's 100 or n or 400 additions into just one multiplication and one division. Boom. That is promotion material. That is like top tier. That is just S tier. That is, at Google, we use the performance rating transformative. And nobody ever got that. That was like the frickin' like, transformative was the top unbelievable, in theory, somebody could get this rating. I don't know if anybody ever did. I don't think anybody ever got transformative, but that means you've changed the game. Gauss changed the game when he was a little tiny little kid. He was a little rowdy kid, and he changed the game. He took something that was that took about n operations, like n additions, and he did this crazy speed up. Like, it's like finding a cheat code. It's like finding a glitch, like when you're speed running a video game. Like, dude, I found this glitch, or like I found this new technique or something. Like, there was a new technique recently found in Super Mario 64. Mario 64, there was a brand new strategy that like shaved just like some tiny little fraction of time, and we have a new world record. Anyways, this is a great way to practice addition, is what I'm trying to say to you. If that's the kind of math that you're talking about as a shopkeeper, go watch episode 1. Okay. So today we're tweaking that previous thing. That was Gauss's trick in episode 1. When will this one be bigger than 3? So you all keep practicing this until I catch up in chat. It's just harder. It's just like much harder numbers. I don't have any great advice. Just start practicing. Even if you don't memorize any stuff, problem solving somehow increases your short and long-term memory. Yes. Like, math is just one of the best ways to keep your brain sharp. It's like the bicycle for the mind not in the like Steve Jobs computer metaphor, but like, it's just a way to keep mentally sharp, I think. It's just a good way to stave off cognitive decline. Like, to me, it's math and music are the two best ways to do that. Permadeath. I mean, I just think Gothslayer, I think you found the right stream. I think, dude, I seriously hope that I can help you, because you are the kind of person I want to help. Somebody who thinks that they're bad at math. Like, that is the audience that I want to reach. So, feedback is a gift. I always say that. First learn number theory? Yeah, Mohammed, let's go. I'm trying to teach calculus from a very number theoretic perspective. Kind of. Does it grow slower because we divide to bigger numbers? Yeah, the denominators are growing much faster. I don't think anybody uses this notation, but I will right now. In the HN, this grows as n tends to infinity. Okay, so as n gets bigger, as n just gets bigger and bigger, it grows and it changes h. Hn grows as n squared approaches infinity. Okay? Because the denominator... Hn prime. Like, this is the sequel. This is the new video game that just dropped. This one depends on the denominator being n squared, right? But now here's the trick, dude. This thing freaking grows so much faster. This thing grows so much faster to infinity. Like, it's crazy how much faster a square number gets big compared to a regular number. If you don't believe me, this is actually a very good practice if you haven't done this one in a while. These are just sequences, dude. These are just sequences, bro. Like, you want to be able to be good at these. What is 1 squared? What is 2 squared? What is 3 squared? What is 4 squared? What is 5 times 5? What is 6 times 6? What is 7 times 7? Here. 8, 9, 10, 11, 12. What is 8 times 8? What is 9 times 9? What is 10 times 10? What is 11 times 11? What is 12 times 12? Okay? I think that this is the most important part of the multiplication table. You can really simplify your entire multiplication table. I think that they call them math facts now, which I kind of love and I kind of hate. But this is the main diagonal in your multiplication table. And if you learn that main diagonal, you can get all the other numbers pretty fast, actually. But what I want to convince you of is that these numbers are growing a whole lot faster than the regular numbers. As n gets big, as n becomes a big number, here's another way to say it. Big number squared is so much bigger than the big number. Like, this is big times big. Big times big is really, really big. We don't need these parentheses. Big is a number. Remember that I'm a programmer, so I'm allowed to, instead of writing X like a mathematician, I cut my teeth at tech companies, and we prefer to use words so that future engineers can read our code. And so that the clever person who no longer works at the company, and can no longer explain, is no longer around to frickin' explain the clever code that they wrote. We like to use words. And what I'm saying is, as big gets bigger. This is fun. I wasn't planning on doing this at all today, but this is a great farewell calculus episode. This could be episode 3 or episode 2. I wasn't planning on it. But this could be episode 2. Should this be episode 2? Anyways, so we are introducing calculus to little kids. Okay. All right. Back to this problem. Who has the answer? What number? When does this cross 3? Remember that H11 was bigger than 3, right? Okay, so let me catch up in chat. Where are we? Where are we? I lost the thing. I lost the spot in chat. Chat is confusing to me. How many chats were there? How many chats? There's no way I can catch up with all this. Dude, this is so nice. Thank you all for watching me. This is crazy. Okay, that one I do remember. One over end of diverging feels kind of spooky. Yeah, Lockheed knows a little bit about where this is going. Yeah, and I love the harmonic sequence because I play classical guitar. And like strings and vibrations follow this harmonic series. Like they literally follow the same harmonic series, the harmonic sequence or something. I don't really know details about it, but I know that is why we call the really nice bell-like sounds harmonics on the guitar. I kind of understand it, but I don't care enough to dig in. Yeah, the super advanced stuff is counterproductive. Lockheed. I mean, that's what I would say. Lockheed said, programming still involves a decent amount of math. Yeah, like coding by hand is so fun. It feels like doing mathematics. It feels like pure mathematics and in the nicest way. On a good day. On a bad day, it doesn't feel anything like that. But not the super advanced stuff. Not the super advanced stuff is helpful, but it does help to have mathematical maturity. Yeah, exactly. In terms of improving career scope, yes and no. I'd say, yes, the most important thing is mathematical maturity. That is the most important thing, and that helps so dang much all the time in programming. Or I imagine, but I don't know, in any freaking, like, technical field, anything that requires problem solving or something. But then you said not the super advanced stuff, debatable, but it does help to have mathematical maturity. The super advanced stuff, though, is counterproductive. If you get interested in really advanced pure math, then it's gonna hurt your job prospects, and you're going to want to live the life of an artist or something. And like, it's not a good idea to go to art school. Kids, don't go to art school. I mean, I don't know. If you're going to make it in the art world, you're going to do it even if somebody tells you not to. You're going to do it anyways, and you're going to prove them wrong. So I'm here to tell you, don't go to art school. And if you are convinced not to go to art school because of me, then good. You wouldn't have made it. That's, yeah. Came across your channel last night. I'll be picking up the basic math book and following along. Let's go, dude. Let's go. I really hope that my lectures can complement, not replace the book. Like, what I'm doing right now could be in that book, I think. And it might be. Like, Lang was a clever dude, and I think, I mean, he wouldn't have used all the zooming in and out with an iPad and all the colors and, like, teaching it like somebody younger, but I don't know. I wonder if he has the same exercise. Like, ultimately, if you squint or something. Goth Slayer got bad at single-digit numbers. Well, that's okay. Like, a lot of people can live life without that, but that basic skill is very, very, very valuable. And I'm going to talk about it a little bit in my next math lecture, whenever I finally get it done. For a brief moment, I will talk about, I spelled this wrong, Fibonacci numbers. If you want to get better, Goth Slayer, at your addition, do this. Okay? Forget I said anything. Just forget I said that. Dude, let's start from the basics. What do you know? What do you know in terms of addition? What's the simplest thing? Like, that's a good philosophy to take in programming. Let's start with the simplest thing and get bigger and more complex until we find something that is trickier. The simplest addition, I think, is 1 plus 1, or arguably 0 plus 1. Either way will work here. This is not a trick question, but what is 1 plus 1? It's 2. All right, what about 2 plus 1? 3. What about 3 plus 2? Can you do that one? 5. Okay. What about 5 plus 3? 8. What about 8 plus 5? Like, I hope you're doing this with me right now, man. Like, that would make me very happy if so. What is 8 plus 5? I'm pausing deliberately to give you a chance. 13. What is 13 plus 8? All right, we're going to keep going. And it's okay if you get stuck along this. You said that you're not the greatest at single digit addition, and we're already in double digits now. So at some point, this sequence is going to get hard for anybody, which is like one of the reasons that I love it for practicing addition. 21 plus 13 is 34. 34 plus 21 is 55. 55 plus 34 is 89. 89 plus 55 is 144. 144 plus 89 is 233. 233 plus 144 is 377. 377 plus 233 is 610. 610 plus 377 is 987. Right? Yeah. 987. 987 plus 610 is 1,590. Wait. Is that right? 1,597. I think. I feel pretty good about that. If you make a mistake, just like resist the urge to ask ChatGPT. Just resist the urge. Don't use your tokens on this. It's not like save your tokens. Keep going. What's the next one? It's okay if you made a mistake. You still got the addition practice. 1597 plus 987. 2,500. Wait. Yeah, 2,584. That's about where I want to stop today. Because at this point, it's going to start getting harder for me. But I don't know if I've ever gotten that far doing this one on my own. So I feel like my mental math is getting better. And you saw where I got stuck. You can keep going. Just set us a freaking timer and speed run this thing, dude. And track it in an Excel spreadsheet. Set a 5-minute timer. And just write it down in a piece of paper, or if you have to, in Google Sheets or an Excel spreadsheet or something. But it's just more fun to get some graph paper. Dude, just get some graph paper and start graphing this. And see how far you can get. What's the biggest number that you can get? Like maybe in this, you're not graphing the number itself, but how many numbers you got. So today in this little session, I wonder if it was 5 minutes or what, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So today, on, what day is it? On July 13th, I got, I forgot, 20 something. 3, 6, 7, 10, 11, 12, 13, 14, 17, 18. So that's, okay, 18. And then do it again tomorrow or next month or something. If you want to get better at addition, this is one of the best ways, I think, to do this. To get better at mental math. And that's what it sounds like you said that you are not great at. I wonder, has anybody found this answer yet? I'm still trying to catch up in chat, dude. I can't believe how many people are watching me practice math for fun. That's crazy. That's crazy. So you can give change to the shopkeeper or count it faster without getting scammed. That is... I am so, sorry that somebody did not do their job. I am just so sorry that somebody did not do their job, dude. Somebody did not do their job correctly. But beyond that, maybe they just never were taught well. Like, math education is just so... It's just like, it's one of these things where, like, you don't know what you don't know. Like, you don't know what you don't know in terms of a different way to study math. Like, you just don't know what you're missing. You don't know how fun pure math is, or different ways to add numbers in your head or something. So, no joke, I really think if you want to get better at your addition, what I just did with the Fibonacci numbers is the way. That is the key. If you want to get good at a musical instrument, it's the same thing, etc. And probably a lot of things in life, honestly. So let me catch up. Where are we? I think it should be a dedicated practice session. It can be fun, dude. It's better than TikTok. Better than TikTok. Minecraft got you into digital logic and hardware stuff. I've seen some incredible stuff with like Redgate and stuff like, or is that what it's called? Like the circuits? Like, people have, like, built Minecraft in Minecraft and stuff like that. It's crazy. That's amazing. Redstone farms. Yeah, I never got into Minecraft, but I know it's just another world. Like, quite literally, it's just another world. Can you get a job with maths if you don't do internships in Europe? Yep. Goth, you just have to do fast calculations or be great at math questions, calculus, algebra, and all. I don't know. Yeah, dude, these are terrific tips that people are giving. Say stuff, that's a great one. To add 9, it's better, it's faster, stronger to add 10 and then subtract 1. And so that's how I added 89 in the Fibonacci numbers. I added 100 and subtracted 11. Like, dude, cheat code. Cheat code for life, like, once you learn that kind of stuff. It's really cool. Really, really cool. And just fun. Like, once you discover these new math patterns, or just, like, a higher degree of number fluency or something, it's like, how did I do it the other way? Like, why did I do it the other way for so long or something? What the heck is computational and technical Minecraft? Like, the pure maths of Minecraft? You are gonna get me derailed, my friend. I hope you're not going to talk about that anymore, because I'm gonna get actually nerd sniped about that phrase that you just said. That sounds really, really interesting. Me, I want to be faster in counting in your mind. I use fingers to count. Lol, I'm 23. Dang, dude, Goth Slayer, like, I'm telling you, I teach kids who do finger counting. I mean it. Like, the Fibonacci numbers, they freaking eat it up, dude. They, like, I actually maintain a leaderboard, and they, like, have a friendly competition, a 5-minute leaderboard, like, as a warm-up before a tutoring session. and they just like eat it up as like a way to practice. And it's like, you made a mistake here, and then all your later numbers are wrong, but like, awesome job, dude. You got, in this league of like one mistake allowed or something, you got really, really far. It's just such a good, fun way to practice, and it gets hard for anybody. And that's just a normalizing, like I'm passionate and I love the idea of normalizing the fact that math gets hard for everybody at some point because it's infinite. Math is infinite. It will get hard for you at some point. It will get hard for anybody. And that's what's beautiful about it. Even if you have an ego and you think that you're really good at math, at some point you're going to come across some questions that are really, really hard that nobody's been able to solve yet. There are no pure math related jobs nowadays. Who knows? Who knows? What's next, man? Who knows? So you were always a nerd. I like mechanisms of redstone farms. In old days, one could have become a scientist and get paid. I'm not going to take that detour. If you like fractions, you might be interested in Fractran. Locke is such an interesting person. How does Locke know all these things? What is that? Is that like Fortran with fractions or something? Like Ramanujan and Hardy. Yeah. Are there any jobs that are related to logic? Yeah, coding. Like the really cool, super hardcore badass, like if you want to work on compilers or something hard, like something like really low level, like those jobs are kind of here to stay for a while. And like really, like software is like, it's just pure logic. You're inventing something out of thin air, out of like a blank blackboard. We just invented a lot of really cool stuff. And that's a lot like what software feels like. Like you build something out of thin air, and now you can show it to your mom, and it's so nice, right? So I hope that makes sense. We're all Minecraft nerds in different ways. Basic maths, 1 + 1 = 2. Advanced maths, prove 1 + 1 = 2. That's true, actually, Mohammed. Good point. Proving 1 + 1 = 2 takes about 300 pages, and there was a book published about that in the early 1900s. Yeah, I can't believe that it takes... I've never understood. I've never read that book. I don't know anybody who's read it, but it takes 300 pages to understand why 1 + 1 = 2, which is a little silly. Like I'd rather just believe it. Like I'm okay with just believing that one, dude. I have this number, or I have this number, and I have this number, and I look at them, and now we have 2. Good enough for me, man. Computer word was used to refer women who used to do big computation work in the past. Mental math is something I peaked at when I cared about competitive math, and now I suck at it. I mean, I love that I've gotten better, actually. I had to relearn mental math tutoring kids, and it's fun. Mental math is actually just fun. Just do it. It's better than this. Like, go. Why are you watching YouTube? Get off it. Why are you watching me? Go just practice adding some numbers together. I do calculation everywhere I see numbers. Like I add number whenever I see time or battery. After that, you start picking tricks. Like Say said, yeah, these tricks. Like one weird trick to add 9, 10 minus 1. It's just so good. It's like that is like kids say like OP. Like that strat is so freaking OP. Like once you learn it, it's really useful. I think I can unlock the secrets of the universe via math. I think a lot of people have thought that, and there's probably a very interesting philosophical argument somebody could make with that idea. That's like, Cappy, I feel like that's actually a surprisingly deep idea that you just kind of touched on that, is going to get my brain spinning later. Never understood how maths and physics are different than each other. Well, on that one, I would be able to argue it, but the first one I'm going to have to think on. Whenever I do maths, there are a lot of calculations, obviously. It takes time, but never use a calculator. You'll get better. Yeah, don't just put away the calculator, put away ChatGPT. Just try to do it on paper the way they did in the olden days. When they invented this stuff, when they discovered this stuff, hundreds or thousands of years ago, they did not have ChatGPT. They didn't have calculators. Just like, this is your opportunity, okay? You get to do math by hand. Like, you get to do it. Like, that's fun. Like, you get the opportunity to solve some problems on a piece of paper with a pencil or a pen, ideally. And you try and you solve the problem, and that's what you were responsible for. Like, you were responsible to solve a problem on paper. It's just so much nicer to look at with your eyes and feel with your hand than a computer screen. Like, I'm not gonna lie, I strongly prefer paper books. Okay, I strongly prefer doing math on paper, but obviously there's a lot of benefits to digital, like, and there's so many things I can do with digital that I couldn't do with paper. So by the way, now that I showed that on chat for the first time on stream, like, look at this cute notebook I got this weekend. I got some matching color notebooks. Dude, this is so inspiring to me. I got cute color matching notebooks at the local bookstore. I was like, I want those. They look like, so all my basic math is in this book. And I don't know if anybody's ever been sponsored by a notebook company before, but like, I want to be sponsored by a notebook company. I feel like I could sell some of those, with links in the description or something. I see. Thanks, guys. Some tutorial for basic mental maths. Math is logic and rigorous. Physics is empirical and kind of rigorous. Dude, I'm so curious if anybody has the right answer on this. Somebody who doesn't already know the right answer. I'm so curious. I'm sure somebody's spoiled it by now, but, somebody's already given the answer. And then it's no fun anymore. You got it spoiled. Are you more likely to get a job in industry or academia with just a math degree? You can do whatever you want with a math degree. It's hard to pivot to industry, but you can, and a lot of people do it. It's hard because you're not directly trained for anything, but you're kind of trained for everything. Like, in a weird way, like very similar to philosophy, which I say with some experience because I did a minor in philosophy, a major in math, and then a minor in computer science. I took a 5th year in college because I was like, shoot, I don't think math is for me. I think I want to get a job in the real world. Let me cram a computer science second major. And then I was like, no, dude, I'll be fine with just a minor. So I trained a little bit for a year, but I didn't learn that much. It didn't stick until I started teaching myself programming in the summer after, and like getting good at actually coding and building apps that I could show my mom. So like, you kind of have to do the work yourself. You just kind of have to do the work. So it's a hard path, I feel, but if you can teach yourself a valuable skill that people pay for, like teaching, I think is super valuable. It's super underrated. Like, teaching is an underrated career choice, I think. If you can learn how to teach other people math, then people will pay you for that. But that's a separate skill. It's a separate degree, potentially. Like, if you get a pure math degree, it's like I hang out with like a bunch of classical guitarists, and they have a performance degree as opposed to an education degree. If you're a performance degree guitarist, you're not qualified to teach at high school. You're only qualified to put on concerts and maybe do private tutoring and things like that. But like you're training in an art field, and it doesn't directly train you for anything, but it trains you for everything in a different way. Like if you can find your field that you want to go into, there are ways that this art will translate over to some other industry. I believe that more and more as I'm getting a bit older. I feel like certainly with math, and it's easier to make the argument because math is like pure problem solving. Math is just pure problem solving. It's just pure math, pure mathematics. So if you want to learn high school mathematics from a pure mathematician, get this book, dude. I don't even have affiliate links. I'm not sponsored by Serge Lang or anything. I think that you should get this book if you feel like you're not good at math, and it's just fun. It's just fun. Just enjoy it. Study this math for fun. And it's okay if you get stuck. Like, he's notorious for having hard books. His books are hard. His writing is hard to read, but it will make you more mature, quote unquote. Like, developing mathematical maturity and the ability to read mathematics is a skill that takes a long time, but it's so valuable just directly to the day-to-day, at least in the software industry, which is all I can speak to because that's all I've worked in other than YouTube, I suppose. So I'm still catching up on chat. I wonder if I'm ever going to catch up to present day. So don't spend time on this? I don't know. If you have fun with it, like if you had a fun time doing a thing, then like was it a waste? Like I don't know, dude. If you enjoyed it, if you enjoyed playing a game, with friends or solo, like was it a waste? Like it was fun. Like I enjoyed that time better than TikTok. Like I mean, if you enjoy TikTok, that's great too. I'm sorry. I enjoy TikTok sometimes, so I'm just, that's metaphorical. But there's just other hobbies that I have that just feel better afterward. Like studying math in a cafe on paper books, like just feels better afterwards, and I feel more recharged. So, if you get bored with like adding numbers together and multiplying numbers together, yeah, there's plenty of other math to learn too. Damn, I don't know what you said, but it looks cool. Like what I was showing you. Is that it? Goth Slayer? I wonder if you're still here. I hope you are. Yesterday I saw a video like addition proof, and today calculus. OMG, I am so far behind. Don't worry, you're not. I'm trying to teach this as if it were a little kid. I'm teaching calculus to the little children out there, metaphorically. I hope that you all can pick up and follow along with what I'm doing, because all we're doing is just adding numbers together. Like, let me revisit in case anybody just tuned in, because probably a lot of people did. Today we're not doing calculus. Today we are doing basic... Oh, wait, sorry. Today we're doing calculus. But last time we did some basic mathematics. Okay? And in my last episode of this channel, and I don't know, maybe I'll freaking just clip this and upload it as a long, hour-long live rant about how I would teach a kid calculus, if I ever got the chance. Like, at some point, this left-hand side is going to get hard for you unless you find a cool glitch. And Gauss found a really cool glitch. He found a glitch that took something from n operations, like n additions. It took many additions, and it was very tedious, and you had to just keep doing it again and again. And he was able to convert it to one multiplication and one division. And then he could just keep studying prime numbers more, which was amazing. So this was a clever trick that he found. And we still teach it to this day, hundreds of years later. It's the same exact argument. It's the same exact idea in like an abstract idea from hundreds of years ago that somebody wrote down on a physical piece of paper. And now I'm showing it to you from a blank iPad, which is kind of like a digital blackboard that I can rewind, zoom in, zoom out, copy, paste. And I don't know, I'm just really enjoying the iPad as a way to lecture. And I think it could be used effectively. And I guess it is. Anyway, so I'm getting derailed. Somebody was saying like, dang, I thought we were adding numbers and now we're talking about calculus. I'm so far behind. You're moving too fast. Actually, no, we just tweaked that math fact. And what I did was every number, I guess I lost the way that it looked. Here, I would rather do this. Today, the new game, the new number game, I should call them number games. That's a good idea. The new number game that we're playing is this number game instead. So we're tweaking the previous number game that we had. I wasn't planning on clipping this, but I feel like clipping this now because I think that this is really fun for me. And earlier we did a little bit of practice involving revisiting mixed numbers, which everybody forgot. Everybody got the wrong answer. But it turns out that this question is much easier to answer if you use mixed numbers. I love that moment. It was like, who has the answer? Wrong. 3 people had the wrong answer. So this is the new number game. So you haven't missed anything. I'm teaching you calculus next, actually. So this, and I promise it is calculus. It really is calculus. I'm not exaggerating with that. So now the new number game, the super hard number game, the harder number game that we're playing now is we're going to tweak it again. And this time, we're squaring the denominators. So we have reciprocal squares. That's the fancy way to say this. And Lang, who's this, clever yellow math book, Lang. Clever yellow Lang. Clever yellow basic math. Like these yellow books are just so beautiful. Like you can trust this brand, I feel, and I'm not even sponsored. Like I would love that would be amazing. But Lang would call this the sum of the reciprocal squares. So we could have done this number table, the squares. We could have found n and n squared, 1, 2, 3, 4. But I think we all remember this one. This one is not that new. It's not that exciting. And you just keep doing that forever. So our eyes glaze over and we remember, yeah, that's kind of interesting. Maybe not that surprising. So I'm just assuming that you remember that part. But here we have the sum, which means addition, of reciprocal, which means 1 over x. Like a fraction instead of the Instead of x, we have 1 divided by x. So another way to write that is that x inverse is 1 over x. And we'll see more reasons why. But it's like, on the one side, you have 2 pizzas, right? Or 3 or something. And on this other side, you have 1 pizza for 2 people. Right? 2 pizzas. So I hope that we're bouncing back and forth between math that some people know, some people don't. On this side, we have 2 pizzas. On this side, we have 1 pizza for 2 people. That's what I would say is a reciprocal. And there's actually, I think, like a Latin kind of connection that you can make there in terms of reciprocal, but I don't know Latin very well. All right, so we're going to find that this new game that we're playing is actually much harder. And the question right now that I'm trying to see if anybody knows is, when will hn prime be greater than 3? And I'm glad that people are practicing with me. I'm still trying to catch up in chat. Yesterday you saw a video like addition proof, and today calculus. OMG, I'm so far behind. The way they're applied is different. Math describes purely ideal objects, mathematical structures, different field than using an approximate real-world situation. I love it. I hope to catch up on it. I can't believe 1,000 people have watched this math lecture that's going on for an hour and 42 minutes now. That's crazy. I like to just drop numbers. So instead of 1,135, I think 11 people are on the other side of this computer screen, and I'm just going to hide that number. That number doesn't need to be there. I wish I could click it. I wish I could click that number on YouTube the way I could on Twitch, where you can just hide it. Somebody email YouTube and tell them I want to click that number and hide it. So, yeah, anyways, I have strong feelings there, but, so anyways, thanks all 11 people who are watching me right now. I can't believe 11 people have watched me randomly get on a soapbox and just start talking about math. That's amazing. That's just amazing. I should say go practice. Go practice. I don't know. No, let's just leave it like that. If I don't, if a newcomer is here, let's remind ourselves, what is this? This is a tweak to our previous game. And here's just like a little shorthand for that. I'm sorry that I haven't had that on screen this whole time, so people are like, well, what is this? But I imagine that chat would have explained. So anybody who's here live would... anyone who's here live would be okay, because chat's got your back. I hope. Really bad at math until I started understanding it myself. Same for everybody, right? Right? There's some tricks you use. Cool. I'm so glad that we're talking about number tricks like that. That's an excellent trick, Sundar. Great point. It feels like it's never going to be bigger than 3. Why do you think that, T? Like, I know that I'm talking to you in the past. T Rhapsody, if you're still here and nobody's explained, like, if nobody's given you hints on yes or no on that, why do you think so? Like, I'm really curious if you can explain why you think that. Bro, when number is large, is it close to 0? Not sure what that means. Physics is kind of inherently applied, yep. But if you look into it a bit more, it's more about finding a mathematical framework into which your observations fit into. I mean, the universe that we live in is just so complex that it has inspired a lot of math. Like physics, we come into like really cool, interesting questions in physics, and then the physicist calls up the mathematician and they're like, dude, I don't understand this thing. Can you help me understand it? And the mathematician is like, I got your back, bro. And they go and try to invent some new math that explains something in physics. Sometimes they work directly together. Sometimes it's the same person who's working both in physics and math at the same time. And that sounds so cool. That sounds like a fun job. That sounds like a really fun job. So that's a little rant. 1 + 2 + 3 + 4 + 5. I'm glad we're talking about that and reviewing the last lecture. Abstract objects is a better word. Yep. Yeah, we're building objects. We're building abstract mathematical ideas, objects. Yeah. It is not possible to be 3. I don't understand why you think that, Mohammed. Why do you think so? Because, I mean, if you think something is true in math, you have to explain it. You have to justify your claims in math. You have to not just say, like, dude, I'm telling you, this pattern is always going to hold. You have to have a reason, and you have to have a formal, mathematical, rigorous argument. So 2 people so far in chat have told me that they think it's never going to be bigger than 3, but I don't know why they think that. But this is your intuition, though, which is great. We're building math intuition here. Sometimes you just feel that something is going to be true, but you don't yet see the puzzle why. But you want to prove this thing. This is your goal. You think that this will never be bigger than 3. Why? Dude, we're always adding positive numbers. How could it possibly never be bigger than 3? Dude, that's a good argument. I just made a good argument. We're always adding a positive amount. We're always adding some amount. How could this never be bigger than 3? I don't understand why we're debating this. You need to convince me. Great claims require great evidence or something. Great claims require great reasoning. I forget the phrase, but yeah. Math was formed by axioms. Yep. Cubes grow much larger than squares. Also, yeah, we could play this game with cubes as well. We could do a double prime, HN double prime. 64, oh, dude, was it 64 terms, Mohammed? So you changed your mind? Yeah, okay, 64. I haven't gone that far. That would be fun to do 64 of these reciprocal squares, but I'm so glad you all are talking about this really interesting stuff. Man, that's so cool to me. I can't believe it. Math was not always axioms. That is an important thing to remember when you go into the weeds of foundations. Yeah. Good point, Locke. Really good point. Math was done without axioms for a long time. And then this guy, Euclid, just published the most beautiful, pretty, amazing book that was so influential for more than 1,000 years. I don't know exactly how long, but that's a long time, dude. 1,000 years is a long time, and we're still studying the same arguments. I've got a copy of Euclid back there, and I still haven't read more than 10 pages or so of it, but it's still as relevant today as it was 1,000 years ago. That's so wild. Yeah. I think squared denominators are getting bigger and bigger, so fractions become so tiny that they either won't reach 3 or it'll take so much time. Yeah, but it's still positive numbers every time, and if you always add a small amount, you're going to eventually get to a bigger... it's eventually going to cross 3, the way that the previous numbers behaved, I think. Like, dude, somebody's gonna have to prove this to me if you want to, if you want to say that that's true. I want to see a proof in the chat. Bro, in future, can we do integrals? Yeah, but I think that to do integrals, like, even though it's really interesting, Mohammed, integrals were first. Actually, integrals historically were the first question and the first thing that we're studying. We're studying, like, area of different objects. The Greeks and others were studying things like the volume of a double cone, probably. Things like these geometric objects that they would try to understand. Like, can we find a formula that tells us the volume of this thing? And the volume of a thing is related to the two-dimensional form of this. So, yeah, like the sphere is a 3D version of a circle. And yeah, so understanding areas and volumes historically was first. So that's a great point, Mohammed. But no, unfortunately, I'm sorry, dude. We are now, where is it? Where the heck is it? Oh, it's at the top of the notebook, isn't it? We've done a lot of pages. We are currently in the farewell calculus tour this week. So I've really enjoyed this really, really pretty book by Taalman and Kohn. But we've never gotten any farther than limits. So today I want to be focusing on this idea and just focusing on the math that we've seen so far and doing something that's really similar to, Gauss's weird trick. But yeah. I'm studying 1 week at a time. 1 week. At these different levels. And previously we've been doing calculus in red for high school practice. But fingers crossed, if my interview goes well tomorrow, dude, it's actually going to be middle school. And that would be really fun. Dude, that would be really fun. And I don't need to practice calculus to teach the younger children. So, if so, then why am I practicing calculus? Like, I'd rather practice some other math if it's just for funsies for me. I love calculus, actually. If I had infinite time, I'd relearn calculus, but if it's just purely for me as a hobby, I'd rather spend more time in number theory and algebraic fields of math. So, we are currently in the farewell calculus tour. Maybe I should say world tour, because we have so many people in the chat, which is amazing to me. So far we have this kind of argument that big square gets much bigger than big as big gets bigger. And that's an interesting mathematical fact. So, I mean, all we've shown is, therefore, our new video game that we've invented out of thin air today that I wasn't planning on doing, this is really fun right now. This is our new video game that just dropped, and I'll say is way harder than than our previous video game. So I'm reading chat. How many axioms? How are these axioms made? These are such good questions, and I'm glad some people... You heard a big square, now get ready for big cubed. Yeah. That's great. Where are... chat just dropped to the bottom. Where is it? Okay, wait, I can pop out chat and I can Command F to find that comment. I hope big cubed is not in this window. Where is it? If I pop out chat, it doesn't get infinite scroll back. Dude, if I just lost chat. No, where I have to scroll back physically to get back there. Let me... Dude, I lost chat. I lost a lot of chat, so oh well. 5181, 7765. I'm pretty sure that is mostly unanswerable because the question is inherently physics. I don't know what that meant. So now we've got... People are writing some weird things in the chat. A squared plus B squared equals C squared. A plus C plus D plus E plus F plus G. Maybe I know what you're talking about, but I lost the context. I don't know what you're talking about. This is a fun exercise? Great. That's awesome, because I think I could teach this to a middle school classroom and they would enjoy it, actually. Yeah. Yes, though most of us, it's math after you know what to apply. Either that or they derive GR from differential geometry and then calculate it. I don't know anything about that, and I would love to learn that. I've always been so curious about GR. General relativity, I don't know anything about that. You might be that, maybe I'm catching up to real time. Like, I remember about 5 minutes ago, 10 minutes ago, 20 minutes ago, I don't know. But I remember talking about the two friends, and sometimes it's the same mathematician who's studying physics and math at the same time. That is very similar, and I was unconsciously thinking of examples like general relativity, which is Einstein's big discovery, and like it's his bigger discovery. He had multiple big discoveries, but it's his masterpiece. Like the GR, general relativity, is Einstein's masterpiece, and it's so mathy. They had to invent new math. So that metaphor that I had before is more concrete in the example of early 20th century general relativity, kind of like crazy mind-blown mic drop moment, change physics forever. Everything has been different ever since. That one and quantum mechanics at right about the same time, two completely different revolutions in physics, and both of them required a lot of new math. And so the mathematicians had jobs, which is great, because we like to think that the math that we invent is useful for something. It's really nice when it turns out to be useful for something, most of the time. Most of the time. I don't even know about most of the time. Maybe rarely, actually, do we enjoy the fact that it's useful, but I think math came first. When what gets bigger than 3? Sorry about that, Cyber Potato. The sum of the reciprocal squares. When is the sum of the... How many reciprocal squares do you need to add together to be bigger than 3? Other relations, other sequences. Play with it. Make up your own Fibonacci sequences and see what you get, actually. That's actually an excellent exercise for this. Try to just make up your own Fibonacci numbers and see if you can get something similar to this exercise. Mathematicians came first, started doing some random stuff until physicians generalized it into something meaningful. Yeah, exactly. Exactly. Sometimes the physicians are asking, we need new math. And then the mathematicians, really eagerly, get to work and make up some new math. It won't cross 3. It won't cross 2 for that matter. Really? What came first? Physics, math, biology, doesn't matter. Cappy, I disagree. Math and physics went hand in hand in the early days. Yeah, so we're back to the idea of calculus. Today's lecture topic is calculus, and you'll hear that Isaac Newton invented calculus, and he kind of did in a very real, meaningful way. But this math that we're talking about at the moment, I don't know the history of this math well enough to say, but I think that we knew this one before Newton. And this is literally, it's not literal, but the core idea behind this exercise is like what you focus on in a pure math version of calculus. In an analysis course, you focus on this core idea that I'm trying to share with you all. Math is the language of physics. Locke, they were surely. I think physics also went hand in hand with philosophy and natural philosophy. Totally. Everything was philosophy for a long time. Then it was philosophy and natural philosophy. And then we refactored or extracted physics and math out of philosophy. And yeah. Hey, what's up, scrollable YouTube? I hope that this was scrollable for you today. I'm having so much fun, and I wonder when we will catch up to chat. Right now is 11:38 a.m. my time. 11:38. So, let me write this down. Like, at this point, it is 11:38, and I'm still reading chat. This is crazy. This is so much fun. I enjoy just getting on a soapbox and sharing my passion of math with you all. Like, I really enjoy this right now. This is fun. I would do this if I wasn't getting paid. I have been doing this even though I wasn't being paid, right? Google says math came first. Really? Congrats on 16. Yeah, 16 subscribers. 16 people are watching me practice math on the internet. I can't freaking believe it. I can't believe it. That's like a good sized classroom. Like, I think I could teach a class of 16 really well. Yeah. I don't know about 30. I don't know about, hopefully. Probably. Really, I like to think that we're at 14 today. I think today we hit 14 students. How many students do we have today? Yeah, it's 14 students. And I don't know if I can handle 20. I just don't know if I can handle 20. The Kerala School of Mathematics. They developed lots of calculus and Taylor series stuff in the 1300s purely for the sake of astronomy. What? I've never heard of this one. Okay, to do. In the 1300s, calculus in the 1300s, I am extremely curious about that. What the heck is that? Locke, if you want to share that in the Discord, I'd be very curious about that. 1300s calculus for astronomy. Wow. Like, some of this stuff just, like, puts you in context of human history in such a weird way that's, like, I play a lot of classical music, and I think about this when I'm playing Bach, and it's like, this is from the 1700s. That's hundreds of years ago. That's so amazing. That's so cool. But I've 1300s calculus. And I mean, geometry, like the old school mathematics of Euclid, like thousands of years ago. That's so just inspiring to me. Like, that we're still trying to understand the same stuff, still teaching the exact same stuff. And we will be teaching the same exact stuff in the future, too. My neck hurts, dude. In a good way, I guess. In a good way. Later, take care, copy, Plagifactorio, never heard of it. Bro, explain infinity, we will someday. Software engineering, JC muted? Are you serious? Are you serious? Am I muted this whole time? Oh my god. Okay, no, you should hear me. I like nearly had a heart attack. You should still hear me. A lot of physics and math people used to do astronomy back in the day. Other people would, okay, yeah. Whew. Sundar said, no Lockheed, he's audible. I know somebody who works there, and I miss working with that person. Which infinite series of Ramanujan? There were many, I think. What does that word mean, by the way? Series. Somebody said that. What is that? We lost Ramanujan way earlier at 32. Yeah, we lost some incredible geniuses, and it's so hard to imagine, like, what would the world be like, if Galois, wasn't taken from... What if he won that duel? Like, he lost a duel. He got in a fight over a girl and lost a duel at 20. If he was just a little faster, if he just a little different, if he slept a little bit better the night before, what kind of world would we live in if he kept inventing math? Because, like, he invented my favorite math, actually. Like, literally, I can't wait to share his math with you all, because it's my favorite out of all of it. And he invented it. He scribbled it down on paper the night before the duel, and then he lost the duel. And the other guy got the girl or something. I mean, who knows if this legend is completely true, but I think we know for sure that he lost a duel, at least. Okay. Infinite series of Ramanujan. Were there multiple? We lost Ramanujan early. There's one which says sum of infinite numbers equals negative 1/12. Yeah, that is... Yep. Oops. Did I just black and white my... No. Okay, never mind. All right, that is another good one. We will do this one someday. This is similar to this idea that 1 plus 2 plus 3 plus... This is the infinite Gauss sum. Gauss found that if you add a bunch of... Gauss found that if you add a bunch of numbers together, all the numbers together, and stop at some point, then this is n times n plus 1 divided by 2. I'm just going to say that this is similar to n squared. This is very similar, like it's on the order of n squared. And I don't know if it was Ramanujan, but somebody did. Somebody proved. Oh, I did this wrong. Oops. So last time we saw that Gauss found that if you stop playing that game, you get this number, which is a number times the next number divided by 2, right? Somebody, and it might have been this crazy, incredible genius Ramanujan, I don't know, says that if you don't stop adding numbers and you play that same exact game forever, you don't get n times the next number divided by 2. We get this crazy glitch. Like in a video game. This is weird. What happened? We broke it. Like, we broke the numbers, y'all. Chat, we broke the numbers. Like, what is this? We broke the numbers. I hope the teacher doesn't get mad at us. We broke it. So this is another amazing discovery just about 100 or 200 years ago, not that long ago. We found this glitch, and it's just so crazy. Because they seem like they should be the same. It looks like this is such a funny glitch. It's just such a funny glitch in the universe. I've never gotten into speedrunning games, but I know some people who have, and I don't know, I've watched some videos and things, and it's just so funny. Like, these games that I played when I was a kid that I enjoyed, like Zelda and Mario and stuff like that, and then people are just breaking the game completely. Like, if you run into that wall and jump 4 times in a row and press this button, then you are already at the final boss. And it's like, what? That's a crazy glitch. Oh my god, dude, are you serious? I will 100% nerd snipe you into learning computational redstone. It's perfect for programmers. That was a long time. I feel like I was talking about redstone a long time ago. We lost Ramanujan. He studies infinite series, so yeah, he gave many. One of the 5 million cases where analytic continuation is taken out of context. I actually have not studied that deeply, but I know roughly what you're talking about there. How about the math behind logic gates, especially all the physical implementations of algorithms at the hardware level? Some of the people who invented this stuff are geniuses. I don't know. Yeah, I don't know. I just don't know. Analytic continuation, I know a little bit about that. Yeah, you need to change the game slightly in order to get that. You need to do some weird moves. But it's like kind of like modding. Like, if you like mod a video game, like with this like DLC or this mod or something, we get this crazy glitch. Like, they dropped like a really buggy, like if you download version whatever or something, then it there's this crazy glitch. I don't know. It's like, it's a mod, kind of. Computational redstone, what are we talking about? Somebody doesn't speak English. I'm sorry that I'm not writing on the board anymore. I'm encouraged to see that the viewership is similar. It's kind of hovering at flat. So, like, people aren't leaving, even though I'm just talking right now and, like, reading messages from the past. So thank you, I guess. Like, I'm very curious to see what the... Because I'm having fun. I don't know. I've never done this before. This is interesting. Collab with Terrence Tao. That would be sick. Dude, email me, dude. I would love to collab. Like, I hope he sees this. I hope somebody tags Professor Tao in the comment section. If YouTube even lets you do that. But tag him one way or another, and, like, can we nerd out about math together? Like, one of my math heroes. Like, that's so weird. That would be amazing. That would just be amazing. I can't believe that that's a serious sentence that is possible all of a sudden. So thank you, everybody. Wow. Physical implementations are not entirely magic, but they're certainly clever. Redstone, Minecraft stuff. I don't care about Minecraft, dude. Stuff is learnable. Learn complex analysis. That stuff is cool. I want to learn more complex analysis for sure. Fingers prove 1 + 1 = 2 just fine. Like, I remember doing that a while ago. Where are we in chat? How far in the past am I? Yeah, I love this analogy because I was tutoring somebody and trying to justify the belief that we just are not going to prove. We're not, like, the simplest assumption, one of the simplest assumptions in this basic math book, like, let's just start from this starting point, is that, like, A plus B equals B plus A. Like, duh, right? Like, if you get 3 apples and they get 4 pieces of meat, then we're going to have 7 pieces of food. If you get 4 apples and they get 3 pieces of meat, I don't know if I said that backwards, you get 7 pieces of food again. Like, even though it's different food, we still got 7. 3 plus 4 equals 7. You know, in one case, you've got a bunch of apples, and in the other case, you get some delicious meat. So even though they're very different physical worlds, you can still argue, like, dude, like, at least we still have 7 pieces of food. Like, if you just think of it as food, it's the same thing as if we had more meat. I know I'd rather have a piece of meat instead of this extra apple, but I'm just, like, ranting. I'm yapping to myself, to a camera, and people are watching me, and I enjoy it. Thank you. I'm having fun. It's better than TikTok. Better than TikTok. If you draw the same thing on a curved surface, straight line, I don't know what that is. Alternative number systems, other societies, 4-digit number systems based on counting animal limbs. Wow, I've never heard that. Animal limbs create like a base 4 number system. Dude, that's cool. I mean, I've been making the argument recently that these are the 10 numbers that exist in the world. Like, these are the this is, to me, the closest thing to numbers. I know that this is a crazy idea right now. Like, dude, look at this, look at this. These are the numbers. I discovered numbers. There are these things. They're very useful for counting pieces of food. Like, this is an invention that somebody freaking made someday, a long time ago, that they had a genius idea that was like, these aren't just useful for grabbing your, like, Apple Pencil or something and, like, petting our kitty cats or something. Like, they're also useful for counting things. I can imagine the idea of quantity and how many of a thing you have, and then I can represent that in the physical world, that abstract idea that I had, and these are really useful for it. And, like, somebody else is like, yeah, but what about your toes? And it's like, I don't know, dude. Like, these are just easier to count with than, like, looking at my toes as well. Let's base all of our numbers on 10. Like, base 10. Let's base everything, all numbers. Let's invent numbers. You can count to 10, and then you can restart and count to 20, and then 30, etc. Which is a cool idea that came up in tutoring just like a couple days ago, 2 days ago, and I had so much fun coming up with that idea. I feel like, dude, I would do this just for funsies. Like, I am doing this just for funsies. I can't believe that we got so many subscribers. We've got 14 students in the chat. 14 students have enrolled in my class, and I don't know when, I don't know if we can handle 15, 16, 17, 20 students, but let's try. Let's see how many students we can get. If you draw the same thing on a curved surface, about alternative number systems, numbers in the Bible. I don't know very much about that. That sounds interesting. I would love to hear a lecture or something about that. iPad is telling me it's almost time to go. I hope I can catch up to real time here. Otherwise, we might have to resume in the future. And I read every single chat because I appreciate every single person who's in this chat and who's contributing to making this an awesome, fun place to hang out and practice math. Thank you. Thank you. Let's see, the same thing behaves differently at different places. That's why we require its proof. We still don't, I think we've all lost the plot here. This is what we're supposed to be doing, y'all. Like, I think y'all got kind of distracted. No offense, TBH. I feel like we got distracted. Let's circle back. Let's circle back. This is what we're trying to understand. Okay? When will that be bigger than 3? I want to see somebody get the answer. It's a JE traumatizer for me. Yeah, I remember now that I did it, but only for passing exams. Yeah, I haven't done it yet. I know somebody did like a JE stream recently, and I wasn't able to join for that, but that sounds fun. Like, I'd like to do a JE stream someday and try to solve those problems. They sound scary. Like, you all have like way more hardcore entrance exams than we do in the US, and it sounds fun. I don't know if I've learned the math that is on the JE Advanced, honestly. I know some of it. I know a lot of it, I think, but I don't know. Data science related math. Yo, what's up, Leo Tom Music? I wonder if you're still here. How's it going, bro? The other Leo, the other regular Leo in the chat, dude. Good to see you. Leo's a good friend of the channel, from the guitar channel. Dude, Leo, I was just listening to our old masterclass together, and I was like, for my fourth private lesson with a student, I think that went pretty well, actually. I'm proud of that. So I don't know if you've ever went back and listened to it, but I enjoyed rewinding a little bit and re-listening to that one. I bet he's not here anymore, but still. In physics, you use logic and math, observe the rules, something that we're in. I posted a video about that once in the Discord. Okay, yeah. It matches with most math books because the Graduate Text in Mathematics series has yellow covers. Yes, that's why I'm saying, like, I would love to get sponsored by that yellow book company because it's so pretty. Like, every single one of those yellow books, like, I just trust I'm going to enjoy reading. They have, like, a brilliant marketing person there. Like, somebody is just like an advertising genius who we should just like study in like future advertising textbooks or something, because they have such a distinctive brand. It's just that like someday I want like this bookshelf behind me to be all yellow books. Like just to have like an entire yellow bookshelf and then another bookshelf with like crazy colors. But yeah, big fan. Okay, we might have to just go. I might not catch up to chat. Nobody got the answer to this one. Antimatter is a famous example. See you later. Engineers should learn pure maths. I think everybody should learn more pure maths. And I hope that I can contribute to that a bit. Engineering pure math is basically just linear algebra. Yeah. Kinda. Let's move a little more quickly to try to catch up. Don't have that book, but I do have books from that author. That's why I got so excited about this one. Like, I know that he writes really well. Like, he's like a pretty clever guy. He's a clever guy, and sometimes he'll make you feel bad, but then if you have the patience and you're okay with it and you trust him as an author, eventually you'll be like, oh, I understand. I understand now. That is actually a really nice way to explain it. But I felt very upset until I came to understand why he explained something that way or something. So, yeah, the fact that this guy made a high school math book, apparently, like, I'm very excited to be reacting to it in real time with you all on this channel. It's crazy. That's so cool. But is this Serge Lang book really suitable for people who haven't passed high school maths yet? Yeah, it is for high school math. Yeah. Exotic matter is undiscovered, hypothetical form of matter with negative or imaginary/complex mass. I think that's all the variations. Teachers teach you to memorize certain methods to solve certain types of problems in JE. Yeah, I don't know much about the JE. I think you should go from bottom, then scroll up instead of doing the opposite. I feel you, Cappy, but I'm enjoying this process because you can't really catch up to infinity. Yeah, there's an algorithmic problem here. If every chat I read gets 2 new chats, I think that we can prove that I'll get really hungry and have to go eat lunch, right? If every time that I answer a chat, there are 2 new chats, I might have to call it a day soon. We're 2.5 hours into this stream, so I got to read them more quickly. What are some cool hobbies besides math, classical guitar? Smart dude. Locke is a smart dude. He is a smart dude. Huh. Oh, you were taught that Ramanujan found the Gauss's weird trick? Yeah, well, they actually, I'm sorry to say, they literally lied to you. No, it was Gauss. It was Gauss. Supposedly, I mean, I don't know. Maybe it's an urban legend, but we've definitely known that one before Ramanujan. I mean, he is a hero. Like, he is a genius, but no, it was Gauss. Supposedly, like that's what we teach. So, who knows? It is possible that it's just independently discovered fact. Calculus supposedly was independently discovered by Leibniz and Newton at the same time. I think it's fair. I think it's accurate to say the fundamental theorem of calculus, which is this connection between two different worlds of math. There's these two different worlds of math, like this old ancient math about volumes and areas and what the Greeks were doing, and something that's more modern about rates of change and apples falling and hitting the ground or something, and the fact that two different objects, if you drop them at the same height, they will hit the ground at the same exact time. That got us thinking about like related rates or rate of change and things like that. I'm talking out of my expertise and my own understanding, but I think it's correct, and somebody correct me in the chat if what they discovered was a connection between these two different worlds. Yeah. Dude, I can't believe that you all are just having fun talking with each other, mostly. That's so cool. Like, we have, like, a really dope little math community now. That's so cool. Y'all are just geeking out. Okay, Torch has an interesting... What does that mean? Why did you say that? Pi squared divided by 6. Okay, wait. Torch. Dude, you're the first person who said something that looks kind of interesting. I think that you win this one. Torch says pi squared over 6. What is that? Well, we haven't yet invented pi yet in this class. Like, all we know are numbers so far, but I have talked to ChatGPT before, and I've seen a button that says pi on it, and I think that I can just multiply that by itself, and if I do that and then divide by 6, okay, it told me that this is about 1.64. So why are you telling me this? What is this? What is this? Like, you're making an argument to me, but you didn't finish your sentences. Like, math needs to be full, complete sentences. Lang is very opinionated about this. Like, math should be English sentences. You can't just say that the answer is pi squared over 6. That's not an English sentence. We need English sentences. And he'll be kind of annoying about it if you read Lang, and it's really funny to see it in basic math. Like, it's so cool to see his writing style teaching high school math, where he's just so strict about math reading like poetry. And there's something so pretty and beautiful about that, that math should read like poetry. Like, he actually had that quote. He actually called it, you should memorize these like a poem, and you should pronounce them out loud. In the third section, he literally said that, and I was just like, that's amazing, because this is what I was expecting. I've been wanting to say this in a upcoming video, that you should be treating math like poetry in a variety of different ways. But Lang is really big about this idea that math should be complete sentences. Try to avoid the symbols. They're very cute looking, but like, they're like the smart programmer who left the building, and they got hit by a bus, and now we hired a new programmer, and the new programmer doesn't understand what the heck the last guy did. It's just too clever. If we write out our math as English sentences, there's a very good argument for that being the right way. There's a good argument for that, I think. So it's funny and really cool and entertaining, and I enjoy it to read high school math with that style. Style is super important, I think. Newton was a peak of science. I don't know. This will make a fun episode 2, I think. I wasn't planning on it. I really wasn't planning on it. I don't know if I'm going to edit it and clip it up or something, but I think that this has been incredible for me. Like, I've really enjoyed this. And it looks like you all are still having fun in the chat, chatting amongst yourselves. But I'm getting better at math right now by explaining some of these ideas I've had in mind to a camera. Even if we are right now at a distance in time. Like, I'm reading your past messages. It's kind of like we're in like a time machine in a cool way. But I'm still kind of lecturing, or that's inspiring certain thoughts for me and inspiring me to verbalize certain mathematical ideas that I've never expressed out loud. And that's awesome. Like, so heck yeah, chat. Thank you, chat. And I'm learning about history with you all. Ramanujan was bullied at Royal Society London. Awesome. Hello, sir. How are you? I'm doing great, Sandeep. Hope you're well. Watching is 36. Dang, really? There are 36 people watching. I haven't checked that number. That's amazing. 36 people are watching me, and 14 have signed up for my class. I can't believe it. I can't freaking believe it. 34 people are watching me on a soapbox just ranting about math and comments from the past. How far behind are we? Right now that I'm talking, it is 12:11. How far back in the past are we? Nobody's yet said, oh my gosh, it's 11:38 or something like that. I mean, I like both math and guitar way better at math than guitar. Okay, I think I remember saying that. G.H. Hardy met Ramanujan. T. Rhapsody is still here. Nice. Awesome. I remember asking earlier. Prolog. I want to learn more Prolog. I learned a little bit in a programming languages class, and it just seemed like super cool. I would love to learn more, diversity of programming languages. Like, there are like some really, really nice looking books about like learn 7 languages in so much time or something, or like 7 interesting languages. I forget what it's called, but it's like pure ways that these different programming languages are built completely differently and make you think differently, even though they can build the same apps at the end of the day. They're all a different method of thinking and a different like implementation, or they have their pros and cons. I don't know. Like, I enjoyed that class very much. Doesn't hn prime get bigger each step? Yeah, exactly. Oh, and the limit from n to infinity is pi squared over 6. Why do you know that? Proven by Euler. Who's that? All right, so now we're making some progress. Now we got something. Oh, it was Torch again. It was Torch. Yeah. Now you justified your answer, and you said by somebody named Euler. I know his name looks like Euler, but no, that's not Euler. This is Euler. Proven by Euler. Interesting. All right, Torch, thank you for following up. Yep. Okay, since pi is less than 4, we can show that 16 divided by 6 is less than 3, and therefore it is always smaller than 3. Boom. I think that counts. Heck yeah. I think that counts right now. You have a gap. You have a reference. You said by Euler. Like, if you go to the library and look up the book by Euler, then you can find that pi squared over 6 is the sum of these numbers. So let me try to write down your argument, Torch. Thank you for the beautiful argument. I hope you don't mind. I'm just calling you Torch. I don't feel like, if you want, I can write all your numbers, your exact handle. But dude, thank you for the beautiful argument. Let me write this out. I'm going to write it out verbatim because I think that's really nice. Well, you said doesn't ... I'll do small tweaks. Hn prime, which is 1 plus ... 1 over n squared. 1 plus ... something or other. Gets bigger every step. I'm going to try to follow your argument that you have here, and it's the first one that makes me pause and really try to understand how it's different versus what I was thinking. Because I was thinking that because it gets bigger every time, and we always add a number, since we're always adding a number, we're always getting a bigger number every time, so then therefore this should eventually be bigger than 3. Like, what's wrong with that? I don't get it. But you said it gets bigger every step. And and the limit from n equals 0 to infinity. I like that, this is a complete happy accident here, but the fact that you made this mathematical argument in the YouTube chat text box forced you to write it in the style of Lang. Like, you had to write these mathematical concepts that usually we write with some like fancy symbols, but you had to write it out as a sentence because YouTube doesn't support LaTeX yet, but you could make a feature request and maybe they will someday. That'd be cool. Like, I'd love to get text support here. TE Chi support, not... Anyways. Limit n to infinity is pi squared over 6. And the limit from... Okay, wait. First, you started a separate sentence here. And, capital A, and the limit from 0 to infinity is pi squared over 6. Proven by Euler. Okay. I believe you. Since pi, I know that when you say pi, you mean this nice symbol, which I think is very useful, and I will use it. Since pi is less than 4, we can show that you said 16 divided by 6 is less than 3, and therefore it is always smaller than 3. You use these capital letters, so I will too, and I like it. I like it. It is always smaller than 3. And then, if you could, I know that you would have drawn the cute little box. So this might be the first proof for some people watching my channel. It's very conventional in math that when you think that you've found a mathematical truth and you think that you have discovered a pattern that will always work forever, you draw a cute little square at the end of it. So Torch made this argument, and I like it. I think it's pretty interesting. Thank you, dude. Let's analyze this. Hn prime is this. I mean, you said it gets bigger every step, and I'm just going to say that when you said it, you meant this sequence. It gets bigger every step. And the limit from n equals 0 to infinity is pi squared over 6. Proven by Euler. I like that clause at the end. That's nice, like the way that you said, like, proven by Euler. How do I criticize what I think is a little funny about how you wrote this? I hope you don't mind that I'm putting you on the spot, Torch, because I'm doing this, in a good way. I hope that you're taking this, in the future. I hope you're taking this the right way. In the future, in the past, or whatever, I don't... For me, in the future, when I read your message, because I'm literally trying to understand you from the past, I guess. Trying to understand... Hope I'm not putting you on the spot. I just think that there's a couple things that we can improve. How can we improve this? So something gets bigger every step. Okay? So does the last video game, right? So why is this one any different? Why is this one any different if last time it also got bigger every step? So it's like, here was your first sentence that you had. Now you've got another sentence that you're beginning here. And the limit from n equals 0 to infinity is pi squared over 6, proven by Euler. I don't know if I have any... I'm out of coffee, but I think if I drink a little more coffee, I think I'm going to understand that the limit from n equals 0 to infinity of what? Of what? Like, the limit from n equals 0 to infinity is pi squared over 6. So what you wrote was... somebody else showed me this. Like, that you can write a limit like this. Limit from n equals 0 to infinity. Well, wait. Is that it? No, that's not quite it, right? But you said that the limit is pi squared over 6, right? No, that wasn't it, though. You said not limit to infinity, but like this, we need to say from n equals 0 to infinity and beyond. Right? So let's make this. Okay? This is my way I'm going to say that the limit from when n is 0, and it's going to start from 0, and then it's going to go to infinity, and the value of this limit is pi squared over 6. What I think you're missing right here, and I think everybody in chat is annoyed by me on this, and probably everybody watching this, is that you need to say the limit of something. Like, you're missing the fact that you're saying, like, you need to say, and the limit of this sequence from n equals 0 to infinity, or this series. If you define, somebody said the word series earlier, and I think that was a good one. If we call these a series, or this term, or this number, or the sequence, or something, like, we're missing something. Something seems odd here. From n equals 0 to infinity, but you are saying that this limit is pi squared over 6 of something. I think what you meant to say here was this instead. I think you meant to say something like its limit, maybe. Like, that would fix it. The other way would be something like a little more verbose, like the limit of this sequence or of this sum is pi squared over 6. But hi, Kaya. By the way, you all, please meet Kaya. She's very shy. I can't believe Luna's not with us today. Instead, today, I guess episode 2, Kaya. We have the other one. Hi, Kaya. She's much more shy. She doesn't show up as much, but I think that she appreciates your proof torch. So she's just gonna hide with my black shirt. But okay. So I think that I'm just being picky because I've been trained by Serge Lang. I've been reading his book, and he really likes writing these full sentences, and it's taken some getting used to because I'm used to seeing the symbols and things like that, but I like how he writes whole sentences, and I really like how YouTube made you write this whole sentence, actually. And this is all coming up on the fly. Like, this was not planned. I thought I was going to be working problems today, but this is super cool, and I'm going to roll with it. But so I think that there's just something a little funny, and I think that you realize that too now. And I think you would have, if you could have edited your message, you would have, edited a couple things and reworded things. Oh, Kaya, she's so cute. Okay, or maybe somebody else, like Locke or somebody, may have tweaked your argument to be like a little more clear, just a little more precise. Because in math, we need to be very precise and very rigorous is the word. I mean, it's just kind of a pretentious word, I feel, but like in math, we need to be very clear about what we're saying. Like every step needs to be very clear, extremely clear. Its limit of this, and you said from n equals 0 to infinity, and I think that this reminds me of how somebody else showed me recently that they recognized this video game, and they saw that that the cover art or something for this video game, like, which I'm just trying to play as for fun. Like we were just working on this as for fun. But somebody said, like, dude, the cover art looks really cool too. Like, have you seen the box itself? It looks really neat. It looks cool. It's got this fancy symbol, and it has n equals 0 to infinity. This really neat squiggly symbol up there. And I think, and supposedly these two things mean the same thing. Supposedly these two things are the same thing. This is just like the cover art, and it's so pretty. I could get this tattooed. I could get this on a t-shirt or something. This is like a cool looking math symbol. I love it. But they're the same, supposedly. And I think that what you were really focusing on was this index notation. But that's not what we were talking about, bro. Like, we were not talking about that. You took us a different direction. Remember, we were talking about this number, this number, this number. This is level 1, level 2, level 3. Like, we're just talking about levels in a video game. We're not talking about a frickin' like I don't know what you mean by that other thing that you're talking about. I'm just playing a video game here, and we've got these. And if I play this for a long time, if I play this all day, all year, all my life, at some point I have to stop. At some point I just have to stop. Because I don't want to, spend my entire life playing a frickin' video game, dude. Like, at some point you have to stop playing video games. You gotta move on and learn other types of math. So we're gonna stop there. This is the only thing we're talking about right now. I want to, instead of writing like a big summation symbol, I heard that the cover looks like that. What we're talking about is this. I see it like this. Like I would rather draw this on the cover. And this is this. I've heard this called the sequence of 1 over n squared. So, oops, that's wrong. This is the sequence generated by terms that are of the form of the sum of the reciprocal squares. This is how I'd rather... I wish that this were on the cover of this game. I like this one instead. So, just like, let's say, I like the word Allah. Allah. Allah Gauss's cool triangle numbers. The triangle numbers, which were the addition of n numbers, which were these really cool, fun numbers. 1, 1 plus 2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, on and on forever. And you can stop at any point. At any point you can stop. Yeah, I prefer this one. So we found a few solutions, or we found a few frickin', enemies, bosses, something. We found like a few levels or something in this sequence. That's not the right one. That was the previous video game. And my iPad is frozen. I think it's telling me that I gotta move on and trust that somebody else tweaked your proof a little bit, because it's really good. I like it a lot. Overall, I want to emphasize that. I like what you wrote. I'm not trying to tear you down or anything like that, bro. I really hope that you don't feel that way, because I think it was great. And you were the first one to make a real, full argument here. And I think it's sick. I think it's worthy of a cute little square. Let's draw a cute little square for that one. I think this is pretty good. But right now, you were talking about from n equals 0 to infinity. I don't know what you mean by that. I am only talking about playing this video game one day at a time or something. Like, one day at a time. If I just play this video game one day at a time, this is how many points I'm getting or something. Like, on day 1 I get X, on day 2 I get blah blah blah. Proven by Euler. Okay, so now you are delegating this proof. Okay, but you're saying it has been shown previously in a previous result. Euler already showed this yesterday in class, so let's just assume that that's true. If we assume that that's true, if we take that as a belief, an axiom, if you have read that book before, then you would believe that this is true. And what you meant to say on this was that that the limit of this sequence, not as n equals 0 to infinity, but you meant to say that the limit of this sequence, and I forget if it's drawn with parentheses or not, but the limit of this sequence is pi squared over 6. And you said, not me, you said that Euler said that this is true. Okay, I believe you, man. I mean, when did he say that? When did Euler say that? I don't remember that. When did Euler say that? Euler said that the sum of the reciprocal squares. Okay. This is called Euler said Basil asked him what this was. Basil was curious. Basil found this video game, somebody named Basil, and then Euler found a solution to it. This is the Basil problem. In 1735. The Basil problem, or Basil, or Basil. I don't know how it's pronounced, but I'm pretty sure it's Basil problem. And Euler solved this problem in 1735. So now I have some context. I can go check out that book from the library and understand it, and then I believe it. You know, but like in math, we have to see the argument, we have to see the proof of something before we can just believe it. It's okay to reference another mathematical result that somebody else made. That's fine. And what you did is you said that Euler showed this in 1735. That's cool. Now, so if we take that for granted, now we have this as a mathematical fact. Like in Lang, he boxes these mathematical facts in a really nice, organized, clear way. So this is in our tool set that we've built so far. And then you said you have this next idea. Since pi is less than 4, we can show that 16 over 6 is less than 3. Is that true? Wait a minute, dude. Okay, you said since pi is less than 4, we can show that pi squared over 6... Did you say that? Since pi is less than 4, we can show that 16 divided by 6 is less than 3. So that this isn't what you wrote. You said, since pi is less than 4, we can show that 16 over 6 is less than 3. I mean, I don't know. Remember, this is in the form of, if pi is less than 4, then 16 over 6 is less than 3. Bro, I don't even know what pi is. Like, I've never heard of it. I've heard of it, but I don't know anything about it. I only know a couple of digits. But in class, we were talking about the fractions, and I remember that 16 sixths in class, we were talking about fractions and how to convert a fraction into a mixed number. We do a division algorithm that this is 2 and 4 6, which is the same as 2 and 2/3, right? And that is clearly less than 3. So QED, your move, bro. Like, you need to, like, I never, in this argument that I just made right here, I never needed this. I never needed this pi less than 4. Not necessary. So, like, really, I can scribble all this out, and it's true. It's just true. Like, we don't need that assumption that pi is less than 4 to show that 16/6 is less than 3. We can just get that from the third or fourth section of Lang. And he hasn't yet invented pi. So I think what you meant to say here is actually that pi squared over 6 is less than 16 over 6, which is less than 3. So I'm being a annoying, critical teacher, because I know, like, you did a pretty dang good job here. I'd probably give you an A or something, or a B, I don't know. But I'm going to mark in red pen, like, oh, what you meant to say here was that pi squared over 6 is less than 16 over 6. Which is less than 3. And therefore, it is always smaller than 3. Like, I love the enthusiasm, dude. I agree with you. I would write it that way, too. I love that. It's just that we're missing something right now in this. We're missing something. Because, like, okay, let's go back. What does this symbol even mean? Like, what? Wait a minute. Infinity. What is infinity? Like, I know that sounds like a shower thought, I guess, but what is infinity? I mean, we've been talking about it all the time recently, but, like, not really. Like, infinity hasn't come up yet. Dude, like, we jumped really far from 1 plus 2 plus 3 all the way to infinity. I'm not ready to go beyond 1 plus 2 plus 3 plus 4 plus 5 and that kind of math. Like, let's go back to this kind of math again, because this is the kind of math that I remember really well. These are sequences. This is a sequence of numbers. I can do one, and then the next, and then the next, and then the next. That's what the word sequence means. So I think that we're still missing something. What we're still missing to fully fix this, I think, is that hn is less than pi squared over 6, which is itself less than what you wrote. 16/6, which is less than 3. And then therefore, with this, I think we may be done. I think we may get to draw the cute little square that's so much fun to write. So, my question to you was, when will we get a number bigger than 3? This is what I was asking about. I.e., how many levels? Like, what is n? Like, how many levels do I need to play in this video game? How many of these additions do I need to do until we get beyond 3? More than 3 points or something in the video game. You're saying that this guy, Euler, has a really weird, cool idea that solves this question, and it was done not that long ago. Like, that's not that long ago, because earlier we were talking about Fibonacci, and we're talking about adding numbers, and that's, I don't know when Fibonacci was around, but I think, if I understand correctly, he used the Fibonacci as an example, Fibonacci numbers as an example to introduce show why Arabic numerals are better than Roman numerals. And we'll talk about that some other day. But if you want to see a great video on that, you could see, how's it pronounced? Tibes? Is that right? I think that's right. Yeah. You can go check out Tybie's channel and Tybie's video on the Fibonacci numbers to see more about that. But, so Euler found a solution and said, bro, that video game will never be bigger than pi squared over 6. Well, he said something very similar to that. It might sometimes go over pi squared over 6, but in this video game, every single number is getting bigger one at a time. They never get smaller. So this sequence will always be less than pi squared over 6. So that's kind of crazy. We need to understand. We have more questions than answers right now, but I think we're pretty dang close right now, man. I like this proof. I think it's pretty dang good. Thank you for it. Thank you, chat. There's no world in which I'm going to catch up reading one at a time at this point. So thank you, everybody. This was so fun for me today. I hope you enjoyed it too. Yay! It was fun practicing math with you all today. And let me just try to read silently and catch up to chat. I'm going to say that Torch got him. Dude, got it. You get to win today's math game. Solved by Torch. I like this. I think it's a good mathematical argument. Let me read. jcpracticing is trying to reach the infinity, bottom of the chat, applying analytical function. Yeah. I'm going to read more quickly now, so it's possible that I will catch up. Will you ever read my answer? I'm sorry, Torch. I hope you stuck around for it. I hope you stuck around. I did read your answer, and I'm surprised you're the only one at this point in the chat that has, given such a good answer for it. JC will never finish reading chat. Disproved. I did read your message. I will finish. Well, okay. You did say JC will never read this message. You said JC will never finish reading chat. So if you all keep chatting really, really fast, I might not ever catch up. And that's still possible. I proved it. Read my explanation. I know I did. And yeah, I hope you stuck around. But if not, you'll see the VOD maybe, I hope. Good for you, dude. You win. You win today. You win. Oh, YouTube accidentally just dropped me to the bottom of chat, and I'm just gonna take it. What's up, y'all? I'm in the present day right now. Whatever project idea pops up in my head, what to know. Cyber Potato, good to see you, dude. Thanks, everybody. 2055 views, that's insane. That was a bug in YouTube's. I gotta go, BRB, Torch, I think you made it, right? I think you saw this, right? Dude, that was fun. I had fun. I hope you all did. I don't know. What I meant is obvious, though. Well, are you talking about my technical feedback on this writing? No, I mean, you would lose points on this. You would definitely if you submitted this to the Library of Mathematics, I think that they would say, I don't know, something seems a little funny about this one. This is a real criticism of mathematical writing, and I guess the moral of today's story, for those who haven't fully gotten it or something, is that in math we need to be very clear and precise with our language, and I know that this is just YouTube. It's just YouTube chat, and you probably would have edited your message if you could. But when you're reading precise, modern, proof-based mathematics, it's based in this type of argumentation. It's based in a logical argument. And there were some gaps in this. And I hope you don't mind that I took it as an example to be a great motivating example for tweaking your argument. The idea of your argument was great. The basic kernel idea of your argument was correct. But we do need to work on proof writing, which is hard. It's just hard. I don't have any better solution to that, because you can read proofs all day long in your books and you can get way ahead reading books on your own, but unless you have somebody else criticizing your proof writing, you're going to have difficulty. You're going to have some trouble, because your proof writing also needs that secondary level of feedback. You can't just read other people's proofs, even though you will learn from those masters by trying to do your own proof first and then compare your proof to their proof or get the student solutions manual or something. But sometimes there's just some things where you meant one thing, and maybe it's a language translation barrier, which is so valid, that could be what it is. But for whatever reason, this level of precision is something that's difficult to learn in math, and it needs, in my opinion, one-on-one feedback. And you did, gold star for you, bro. You got it. But I hope you see the feedback and that it was helpful. So, thanks. Okay. Unfortunately, I really gotta go right now. I really gotta go. Dude, I had so much fun today. Thank you, everybody. Thank you. I was not expecting to do this at all. but we just did 3 hours, 20 minutes on this really fun problem. Somebody just asked, how would you explain calculus to somebody who doesn't know anything about calculus? And I think that this idea of like limits is just an excellent way to talk about calculus. And really, this mystery, the fact that these numbers will always be less than this other number, this is the heart of calculus, or at least the beginning of calculus, chapter 1 on limits, and there are ways to make it just like really, really, really precise, which is amazing. That's amazing. Thanks everyone. Bye. I gotta go. Bye. Feedback is a gift. Seriously, feedback is a gift. Feedback.jcpractices.com. If anybody wants to let me know if you enjoyed this or didn't enjoy this, this was a very different style of stream than in the past, and we just made it up as we went. So, also leave a comment in the comment section if you didn't enjoy this. Yeah, I'll solve some JE problems sometime. Take care. Bye.